So problem 4 from exam number 3 are the two clicker questions. And of course, these are both in your lecture notes, but let me talk you through them. Problem 1 says a 1 kilogram rock falls 5 millimeters from rest before hitting the ground. That's 1 kilogram, falls 5 meters, hits the ground. What's the force with which it hits? And the answer is D. I don't know, because the force with which it hits is related to the collision with the Earth. Now, the original velocity you could find, the original velocity would be the square root of 2gh, mass wouldn't matter. The final velocity would be 0 when it hits the ground, but in order to work out an acceleration from that, or a force, if you like, from dp dt, from sort of our other definition of force, or from our idea of impulse is delta p equals the integral of f dt. Any of these concepts requires the time for the collision, not the time in the air. That's irrelevant to the force that the rock exerts on the ground during the collision. So D is the only reasonable answer for this part. Okay. Problem number 2, clicker question number 2, has to do with the tangential acceleration of the Earth about its axis. Well, you shouldn't have to think hard about this one. Is the Earth's rotational speed or tangential speed of some point changing? Okay, at least in magnitude. And the answer is, you better hope not. Earth's rotation isn't speeding up or slowing down, so its tangential velocity at Cleveland isn't changing in magnitude. Now, the direction's changing all the time, but the magnitude of it isn't changing. Okay, so the only answer is 0, is the tangential acceleration. And if you want to say anything more about that, I guess you could say that a tangent, okay, equals alpha times the radius of the Earth at Cleveland, or the radius of the circle that you're going around at Cleveland, and that would involve the cosine of lambda, etc. So if we're talking about a radial, you need to use that term, okay? But alpha is 0. Alpha equals d omega dt, and omega is roughly constant. You had a homework problem about how much it does, the very little, small amount it does change. So that's problem 4.